वेलकम टू फिजिक्स मेड इजी चैनल। आज का जो हमारा टॉपिक है ये फ्रीक्वेंसी रिस्पांस करेक्टरिस्टिक्स ऑफ एम्पलीफायर, और इसके बाद हम गेन पढ़ेंगे और उसके बाद वी विल डू द कंपैरिजन ऑफ three kinds of amplifier and then a look at the circuits and a brief introduction to feedback. These are the main areas on which we shall focus in this lecture. Frequency response characteristics of an amplifier. It's a graphical study of gain. Gain is plotted along y-axis. AV. This is output voltage divided by input voltage. Frequency is plotted along x-axis. This is the frequency of the signal. Now, when the frequency is low, then with the increase in frequency, there is an increase in gain of the amplifier. And at a particular point, it becomes constant and it reaches the plateau, and beyond that, if we increase the value here, it has reached the plateau. Now if we increase the value of frequency, then gain remains constant, and then at a particular point again, with the increase in frequency, it starts falling. So this is the basic graph of variation of voltage gain with frequency, with low and high frequency. With increase in the region of low frequency and high frequency, with increase in frequency, in low range gain increases, in high range gain decreases, in mid frequency with increase in frequency gain remains constant. Now this is a black box diagram of amplifier, and we shall be focusing on feedback. So here this triangle represents amplifier, V0 represents here output, this V0 is output, and this RF is feedback resistance, and this RI is input resistance, VI is the input, and one terminal has been earthed, one terminal of the amplifier has been earthed. Now, for output inverting amplifier, for example, common emitter amplifier inverts the output. For common emitter amplifier, AV is VO by VI. This is equal to minus RF by RI. Now, what this feedback does, this takes some part of the output and supplies it to the input. So some part of the output is fed back to the input. Now negative sign indicates that output is out of phase with input. We have already discussed out of phase and in phase signals. This signal here is out of phase. This is input signal and this is output signal. And this signal, when it increases in positive half, this decreases like this. So they are out of phase by 180. And now this is the basic formula for transistors. Remember, this IE is equal to IB plus IC. Divide both sides by IC. IE divided by IC is equal to IB divided by IC plus 1. Now, IC by IE is alpha, IC by IB is beta. Now what I shall write, 1 by alpha is equal to 1 by beta plus 1. So 1 by alpha is equal to 1 plus beta divided by beta, or alpha is equal to beta divided by 1 plus beta. So this is the value of alpha. On the same lines, we can calculate the value. This is the case of DC. Same is applicable to alpha AC. Alpha AC is beta AC. AC is alternating signal. And the expression written above is for direct current. On the same lines, beta AC can be written in terms of alpha AC like this. Now here, if the base region is made thick, important point is if the base region is made thick, IB will increase and IC will decrease. Due to this current, the current gain in common emitter mode will decrease. The common emitter amplifier is preferred. Note this point. This is very important point. Common emitter amplifier is preferred over common base amplifier because of current gain. The voltage gain and power gain in common emitter amplifier is greater than that in the common base transistor amplifier. So this paragraph is very important. Common emitter amplifier is preferred to common base amplifier due to two or three reasons. One is its current gain is large, and second is its voltage gain and power gain is also large. So here we have got comparison, and in the first column we have got the characteristic or the property, and on the second column we have got amplifiers, common base, common emitter, and then common collector. Input resistance is low in case of common base, medium in case of common emitter, and very high in case of common collector. Output resistance is high in case of common base, medium in case of common emitter, and very low in case of common collector. Current gain is low in case of common base. It is high in case of you can say common emitter amplifier, and it is high as well in case of common collector. Voltage gain high in case of common base, high in case of common emitter, and low in case of common collector. Power gain is medium in case of common base, high in case of common emitter amplifier, and low in case of common collector. Phase difference. Phase differences are zero in common base and common collector, and they are very high in case of common emitter. So these three factors are to be noted. First, these two factors are very important. In fact, three factors, because current gain, power gain, and voltage gain, all three they are high in common emitter. That's why common emitter amplifier is preferred over common base amplifier. And the common collector amplifier is just used for impedance matching. When you have to match high input electronic device with low input electronic device, you may use common collector amplifier. Next is feedback amplifier. We just had an idea about feedback amplifier. Feedback amplifier and transistor. Positive feedback. What is positive feedback? In which a portion of the output, for example, this is output signal, a portion of this is fed back to the input. And now this portion fed back and the input, they are in phase. This is increasing and their shape is same. They are in phase. Their phase difference is zero. Beta is the feedback factor. It is the percentage of output fed back to input. Beta is feedback factor. A, voltage gain without feedback. AB is the loop gain. Voltage gain with feedback, you can say. AB, A beta, voltage gain with feedback. A, voltage gain without feedback. Positive feedback. What is positive feedback? AFB is overall gain of an amplifier with positive feedback. So this is equal to, this is with positive feedback, A divided by 1 minus A beta. With negative feedback, this is A divided by 1 plus A beta. Note down that there is a difference of minus. In negative feedback, here it is positive. In positive feedback, here the sign is negative. And A beta is loop gain, beta is feedback factor. Means the percentage of output fed back to the input. Now we have got a very important criteria known as Barkhausen criteria. In Barkhausen criteria, we put the value of A beta is equal to 1. When we put the value of A beta is equal to 1, then what happens for positive feedback? A beta, here he has written wrongly, feedback gain. I will write the formula here for positive as well as for negative feedback. For positive feedback, I will write here for positive, just positive sign, positive feedback, A divided by 1 minus A beta. Now, if A beta is equal to 1, this implies that gain in positive feedback approaches infinity. So here gain becomes infinity. This state, which states that there is output without any input. Because gain is, you can just write gain is output divided by input. A positive. Now A positive approaches infinity. This implies V approaches 0. Input approaches 0. It means we shall be having output without input. This means that the output is self-sustained. This line is very important. Output is self-sustained. In such a situation, amplifier becomes oscillator, and this criteria is known as Barkhausen criteria. Remember, this Barkhausen criteria is very important, has been asked in your examination. This is a particular situation when amplifier becomes oscillator. Barkhausen criteria is the situation when amplifier becomes oscillator. Now we will discuss how transistor can act as an oscillator. Oscillator is an electronic device which produces electric oscillation of constant frequency amplitude without requiring external input signal. This line is very important. Without requiring external input signal. And it converts DC energy into oscillatory energy. Principle of oscillator. Now what is the basic in an oscillator? We have got transistor amplifier. And there is an LC circuit which gives you the input. Input from LC circuit is given to a transistor and some part of the output is fed back to this LC oscillator. So for an oscillator, we need transistor, we need a tank circuit or LC circuit, and we also need a feedback circuit. Tank circuit, we have already done LC oscillators or LC circuits. We have done LCR circuits in AC current. And in LCR circuit, suppose this is an inductor and this is a capacitor. In LC circuit, the oscillations, the frequency, LC frequencies, the formula for LC frequencies is this. We have done this in detail. In this case, the energy oscillate between an inductor and capacitor. That is, in case of inductor, it is magnetic energy here. At some point of time, whole of the energy is magnetic energy. Here, magnetic. Then, after some particular time, it becomes electrostatic energy. And this capacitor again discharges. So in this way, energy, once it takes the form of electrostatic energy, in the next cycle it becomes magnetic, in the next cycle it again becomes electrostatic and again magnetostatic. So in this way, energy keeps on changing its form. Initially we have got electrostatic energy here, q m square by 2c, and ub is 0. And in this circuit, electrostatic energy is 0 and ub is half lim square by c. And now as the current flows through these wires, so some of the energy is lost in production of heat. That's why their amplitude goes on decreasing. So we have got damped oscillation, and to remove this damping, we make use of positive feedback. Rest of the topic will be discussed in my next lecture. Kindly share, comment, and like it. Thank you very much.